Hi viewers, this is Sri Ramulu, degree lecturer in physics. My YouTube channel is s.s space physics. So before watching this video, please subscribe, like it, share it, and if you have any doubt or if you want to ask anything such as uploading some more videos, please comment in comment box. Okay friends, so today's topic is Joule-Kelvin effect and a liquefaction of gases. Okay, so by using Joule-Kelvin effect, how can we make the gases into liquid? So that is a liquefaction of gases. So first, Joule-Kelvin effect, let me explain one by one. When a gas under a constant high pressure is passed through a porous plug to a region of constant low pressure, there is a change in its temperature. This is called as Joule-Kelvin or Joule-Thomson effect. See here, when a gas under a constant high pressure. So suppose the device is like this, in this manner. Okay, so let here I kept two pieces of metals, and I made small holes to these metal pieces. Okay, like this, and let it is filled with either cotton or silk or any other material. Okay, or any other material, and let this side one piston, and this side is also another piston. Okay, and let it is A region, and this is the B region. So piston in A region, so pressure in A region is P1 V1, right? P1 V1 pressure and volume, and this side P2 V2 pressure and volume. Suppose if we press this piston, then what happens? Piston can work on the gas, then gas comes under high compression. Okay, so then this region may be high compression, high pressure region. Okay, then these high pressure gases can pass through the, this is generally called, it is a porous. Okay, so whole this region is called porous plug. So when the gas, high compressed gas or high pressure gas passes through the small holes of this plug and enter into this region, B region, then what happens? So certain change in temperature will occur. So change in temperature means sometimes temperature may increase and may decrease. That is depends upon the nature of the gas. Okay, then this piston moves backward, so that means here at low temperature it maintains, and it maintains high temperature. So when the gas passes through porous plug from high pressure region to low pressure region, then temperature change in temperature occurs. This is called Joule-Kelvin effect. So following points are observed. So from this experiment, following points are observed. All the gases when passed through a porous plug suffer a change in temperature. Okay, all the gases which are passing through this porous plug suffer change in temperature. At ordinary temperatures, all gases except hydrogen and helium suffers fall in temperature. That is called cooling effect, while the hydrogen and helium suffers a slight rise in temperature is called heating effect. Here all the gases except what? Hydrogen and helium. All the gases means except hydrogen and helium, all the gases suffers fall in temperature. Their temperature falls down when they are passing from high pressure region to low pressure region. That effect is called cooling effect. If we allow the helium or hydrogen from this region to this region through porous plug, there to their slight rise in temperature will occur. So that is called heating effect. The change in temperature is directly proportional to the pressure difference on two sides of the plug. Okay, so change in temperature, so change in temperature, it depends upon what? The difference of the two pressures only. Okay, directly proportional to two pressures. So pressure difference is more, then fall in temperature or change in temperature is also more. As the initial temperature of gas rises, initial temperature of the gas rises, the cooling effect changes into the cooling effect. What happens? Completely disappear. Okay, initially gas has a certain temperature, rise in temperature, then cooling effect cannot appear. At a certain initial temperature known as inversion temperature, cooling effect is converted into heating effect. Okay, so cooling effect is changes into heating effect where at a certain initial temperature. So that temperature, what we call that temperature, is called inversion temperature. At inversion temperature, cooling effect converted into heating effect. Okay friends, so this is what Joule-Kelvin effect only. Next, liquefaction of gases. Liquefaction of gases using porous plug experiment it is. The porous plug consists of a compressed porous material, cotton, wool, silk fibers. Okay, so porous plug consists of what? Compressed porous materials. So porous means the material which has small or tiny holes. Porous material. So see, the porous materials are cotton porous material, and wool is also porous material, silk is also porous material, etc. Having a number of fine holes. They have the very small holes, and the holes also called as pores. Fine holes also called as pores, and is thus equivalent to the number of a parallel narrow orifices in parallel. Okay, orifices means what? Orifices means the small holes which has certain length. So holes which has certain lengths, those are called orifices. Okay, the effect may also be shown with a single orifice. So this effect also can be shown by single orifice. So here see the diagram, it is a diagram, porous plug experiment diagram. The porous plug pipe divides the cylindrical tube C into two parts. Okay, so here porous plug, it is a porous plug. So it is dividing this cylindrical part into two parts, above part and below part. The lower end of this tube is connected to the pump through a long spiral tube. Yes, see this lower part is connected to a long spiral tube. Okay, so spiral tube. Yes, the whole arrangement is enclosed in a constant temperature bath. B. With help of a thick layer of perforated brass disc. Okay, so this whole thing is, see, the whole arrangement is enclosed in a constant temperature. It is a bath. B is a bath. It whole is a bath. Inside it, this experiment is kept. The temperature of lower thermometers T1 and T2 respectively. So let its temperature is T1 and its temperature is T2. Okay, so like this. So that means this side one thermometer is kept and this side is another thermometer kept to measure the temperatures. The gas under investigation is first compressed with help of a compression pump. So to which gas we are going to know that their temperature, whether their rises temperatures or decreases. So that gas have to kept here. Okay, so it is a compressor. The rise in temperature. The rise in temperature of the gas due to compression is compensated by the water bath. So when the gas is filled with, and if you push it with a piston, what happens? Certain heat will produce here. That heated gas can pass in this direction and enter into the spiral tube, and spiral tube is inside the water. Then what happens? This heated gas, heat energy, gas of the heat can be come outside. So that means outside water can be absorbed that heat. The rise in temperature. Okay, when the compressed gas at a constant high pressure P1. So here it contain high pressure P1. Why? Because from this side we are pressing. Passes through the porous plug. So this high compressed gas comes in this direction and enter into this region and later passes through this porous plug. Okay, so now when the compressed gas at high pressure P1 passes through porous plug, suffers a large drop in pressure. So suffers a large drop, so that means at high pressure it is a low pressure. So what happens, it suffers a large drop in pressure, so their pressure suddenly falls. The pressure of incoming gas P1 is measured by the manometer. So this side one manometer will keep to measure its pressure, while the pressure of the outgoing gas P2 is equal to the atmospheric pressure. So its pressure is equal to this outside region pressure. Okay, so then when we take the difference of these two things, then we can know easily how much temperature is fall. Why? Because temperature is change in temperature is directly proportional to difference in pressure. Okay, so if a difference is more, and then what happens, change in temperature is also more. Okay friends, so this is, don't forget watching this video till the end. Okay friends, thank you.